In this lecture, we will learn about deletion of one node from a binary search tree. So insertion, searching of nodes, elements is easy, but deletion of node from binary search tree is one of the most difficult operations that is performed. Okay, so if you're asked that delete a node from a given binary search tree, then what needs to be done? So we will analyze that and try to answer that problem. So if you are given a node which needs to be deleted, so three cases will arise. So three cases. First one is that the node Z, the pointer to that node, if that node needs to be removed, it might have no child at all. So it has no left child, no right child. So this case is one of the easiest case. So this is easy, very easy case. Next in the difficulty level is if the node to be deleted has exactly one child, either the left child or the right child. So if Z is this, it has one left child, or Z has one right child. So this is the next. The third one is if Z has both the left child and the right child. So this was medium, one child, two child. So it's the easy, medium and difficult. So this is difficult. And we will look at how to solve the three cases. So first case, the case one is very easy. No children. Z has no children. If this is some kind of tree here, this is the parent of Z. So what you need to do, so this can be your, Z can be your left child of its parent, or it can be the right child, isn't it? So what we do, so here in tree deletion, we are having 3 pointers in a node. So the node has a left child, a right child, and it also has its parent pointer. So what you need to do is that you need to just make the left child of the node as null. So in this case, I will just make this equal to null. Then this will be deleted, and its parent should be made equal to null. So here what happened, this is the Z. So what we do is that we will do is left of parent of Z. So left child of parent of Z will become null. So which means this connection is gone. Now this node is not there, and you have to update its parent also and delete the node. So this is an easy case. And similarly, if it was something like this is the node which needs to be deleted and it's the right child of some parent, then make the right child of this parent as null. So this will become null, this will be deleted. So this case is easy. So parent of Z, so we will do it, parent of Z. So its left child, if it is a left child, Z is the left child of parent, its left child will be made null. If it is the right child, Z is the right child of its parent. If this is the right child, then its parent right child will be made as null. The second case, if the node has exactly one child. So what will happen? These two cases will arise. So this is Z, and let's say it's the left child of its parent. And now what happens? This Z has left child. It has only got one child, which is the left child. Then what we will do? So we can just make the parent's left child as its left subtree's root. So this will do. I have to remove this. I will just make a connection like this and remove this. If Z is like this, it is the right child of its parent. Again, I will make parent's right child equal to the root of its right subtree. So these are the cases. In fact, it can have one child, so it can be here also. So now in both the cases, if there was this node has a right child, then also its left child would have become the root of its this right subtree. Okay, so how we will write, because we have both the parent and the parent pointers and the nodes pointers. Okay, so for this example we will write, so this is z, so parent of right of z. So let's see this thing. So right of z will be this, so its parent will now get connected to parent of z, and the right child of the parent of z, so will be now connected to right of z, and this needs to be removed. Okay, so this is how we make the connection for one child. Next comes the difficult case, is that if you have case 3 where the node has both its left and right child are there. Okay, so let's take this example. So what we do here is that we want that, okay, we want to remove this node, but it has both the left subtree and right subtree. So what we do, we find the successor of z. So successor of z will be here the minimum value node in the right subtree of z. So what we do is that find successor of z in the tree, which will be in the right subtree of z. The smallest element in the right subtree of z will be the successor of z. So we replace key and data of that successor with the key and data in z. And why is this correct? Because here everything, this node key is less than every other node's key here. So if I replace the minimum with this one, so it is fine, because this will be less than every other nodes here. Okay, so I replace here, and now when I will have the minimum value node here, which will be a duplicate of this, so this will have no left child, it might have a right child. So now this will become case 2 or 1, where it has to delete, we have to delete a node with one child or 1 or 0 child, which can be done easily. Okay, so this, if you are feeling it difficult, we have examples, so don't worry. So let's see first the third one itself. So we have this tree, and I want that, okay, I want to delete node 5. So this is z. If I want to delete this, and this has a right subtree, I try to find the successor of 5, so which is the smallest node greater than this. So we come to this tree which has root as the right child of 5, and here we try to find the minimum value. So it is node 6, this becomes y. Now what we do, so this is the successor we have found for 6, we replace this data here. Okay, so replace this data is copied here along with its satellite data. And now what happens when we have copied this here, so we have duplicate here also. So what we do, so now we have to remove this duplicate. So delete y, it is easier, because now it will never have left child, because then it will become smaller and it can never be the successor of 5. So this has only at max 1 child, and even if 10 was not there, it would have got 0 child. So now we will have to delete 6, which is case 2. So how to delete this? 11 will directly point to 10. So 11 will be the parent of 10, 10 will be the left child of 11, and 6 will be removed. So this happens, and this is the case 3, which involves first swapping the value of its successor to that node and then deleting the duplicate successor, and it is easy now because it will be case 1 or case 2. So let's see case 1 also. Case 1, here we have to delete, let's say, node 14, this one, because it has no left and right subtree. So simply what we do, we make the right child of its parent as null, okay, and we delete 14. This is simple. Delete 18. So 18 has one child, the right child. So what we do, so this is z, so parent of z is this one. So right of parent of z will now become equal to right child of z. So this way we connect here, and then parent of right of z will be equal to parent of z. So both way the connection is made. Okay, and this is how it happens. Now 20 is here. So now just let's look at the code. Okay, so how the code will look like. So tree remove node, the tree is there, z is the node which we want to remove. So let's see the first line. If left of z is null or right of z is null, it means it has either one child or no child. Okay, then in that case what we do? So we make y is equal to z. Okay, so let's see it for the third case, this code. So we have here, we have for node 5 we have z is this one, we have left child, right child, both are there. So what will happen? We will have left of z and right of z both are not null. So we come to this else part. Y is tree successor, so we find y which is the successor of z. So we come here, so successor of z is now this one, y. We find y. Now what we do? So let's try to see. So what we do is that if left of y is not null, so let's see, if left of y is not null but it is in our case null, so what we do? So we have x is right of y, so we make x as right of y. So x now points here, and then what we do? If x is not null, parent of x is parent of y. So x is not null here, and parent of x now becomes parent of y. So x is now getting connected like this, 10 is getting connected to 11, and then let's see, we have to also make 10 as the left child of 11. So what happens here? If parent of y is null, so if parent of y is null, which is not the case, so it is not followed. So else what happens? If y is left child of its parent, so if y is left child of its parent, then x will also be its left child. So what we do here? We make left of parents y is becoming now equal to x. So its 11's left child is now 10, and what happens now? Y is a node that is duplicate. Here also there is a 6, and here also there is a 6. So what we do? So this data is copied here. So if y is not z, then key of z is key of y. We copy it and copy the satellite data also. So this works for this code. So similarly, if you see, this will work for all other cases also. Okay.